Welcome to a Physionic detailed study analysis. We're going to be going over a whole host of different studies to find out if collagen supplementation can actually help us reverse our skin aging or the insult that occurs to our skin over time, if that's environmental or just intrinsic aging. So the way this is going to work is I'm going to go over some of the physiology of supposedly the mechanisms of how collagen has an effect on our skin. And then from there, we're going to go into a multitude of different studies, which means that this is going to be a really lengthy video. If you've clicked on this, then most likely you already see that the timestamps are quite lengthy. So if you'd like to skip to the conclusions, please feel free to do so. However, as we go through each study, as we go through the data of each study, there are some nuances with each study that tell us some slightly different information. So if you'd like to know all those nuances, then I certainly encourage that you watch the entire video all the way through. But with that out of the way, who am I? If you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD candidate in molecular medicine, and this is what I do. I take a whole host of different studies. In this one, we're going to be going over 11 studies with an additional, I think, 8 or 9 that are added to this analysis through a meta-analysis. I'll get to that once we get there. But I take studies and I make them more understandable. I break them down so that you can actually see the data for yourself and make your own conclusions. You don't have to believe what I have to say. You don't have to believe my conclusions. You can certainly just look over the data for yourself because I'll be showing it to you. Okay, with that preamble out of the way, let's go ahead and look at what the research has to say. So, as I mentioned, I'm going to go over understanding the mechanisms of how collagen actually has its effects. Then we'll go over, we'll review the scientific evidence for if collagen truly does have this anti-aging, the skin anti-aging effect, which is going to be 11 studies, so it's going to be a while. And again, as I'm going to put timestamps so you can skip to the particular studies that you're interested in, but keep in mind that each one of these studies, sometimes they add particular nutrients or they might have supporting nutrients or whatever. They might have slight changes to them, which might be of special interest to you. So I'll make sure to add a few details so that you know what the study is about before you commit to going over the data with me. And then for my Physionic insiders, I'm also going to be going over the optimal dosing and the dosage strategy based off of all the studies put together. And then common supporting nutrients. There's a whole host of different nutrients that these studies or that these researchers end up using. So I'm going to go over the supporting nutrients as well as the amounts that they use for each one of these supporting nutrients across the 20 studies. And then stopping collagen. So if you were to stop collagen, assuming that there is an effect, do you see a reversal of these effects? Might be important to know as well. To give you a bit of information on all the different studies that we're going to be going over, let me remove myself for a second. These are all the studies, so there's numbers associated to each one, so that if you decide to click on the notes, then you can have a little bit more of information on each one of these studies, including the DOI number if you want to look it up for yourself, as well as whatever amendments may appear to this video if I make some sort of mistake. Somebody finds some mistake that I've made, then I add amendments to the video, but as well as to my notes, so that anybody that downloads the notes can see those mistakes and see the corrections for those mistakes. Okay, that said, let's go into understanding the mechanisms. All right, so this is not to say that, as we go into the mechanisms, that's not to say that this is proof that collagen has an effect. This is largely information that's gleaned from in vitro studies, animal studies. We're going to go into the human studies of does collagen actually have an effect in the next section. But I think, certainly Physionic is built on this idea that we learn things from the macro to the micro. It isn't just, does collagen have an effect? Yes, no, okay, let's move on. I mean, I'm super interesting. I'm massively interested in understanding how do these molecules actually have an effect in our cells. So that's what we're going to do. All right. So to give us a bit of background, our body is filled with collagen. It's one of the most abundant proteins that's found in our system, and you'll find it in all kinds of different areas, kind of unconventional areas in our body, and certainly skin is one of them. Now, here I've got a depiction of a collagen fiber. Technically, this probably should be a collagen fibril, since it's a triple helix that it just looks like a collagen fibril, but we'll put that aside. Collagen fibrils go into collagen fibers and make the thicker collagen fiber cords. But I'll put that aside for the time being. Okay, so here we've got a cube of skin. We've got the very outer layer of skin up here, and then we've got a kind of a middle section of skin known as the epidermis, and then we've got this larger section of skin called the dermis, and then we've got the hypodermis, but we're going to be focused mostly on the dermis for this discussion. So the dermis is where this collagen is predominantly found. So the collagen fibrils make up a large part of what's known as the collagen matrix. The collagen matrix is a area outside of our cells. It's essentially a scaffolding structure that's found within the dermis that holds this skin up, so it keeps it nice and flat, and that's what gives us this youthful look that we so desire. And well, certainly also that when we're young, we have this youthful look, but over time, we end up generating a considerable insult, and I'll show you some of those insults over time. Another area that we don't really focus too much on, but it's not just about the extracellular matrix, it's not just about this collagen matrix that holds up the skin, it's also about the cells that are found in the skin. So the skin there's keratinocytes that are probably the most well-known in terms of skin cells, but the ones that we're most interested in for this discussion is fibroblasts. So fibroblasts are found in the dermis, and they are actually the ones responsible for the formation of collagen. So they actually stitch together amino acids and then end up releasing those amino acids, or those stitched together amino acids, and add those to the collagen matrix, so replenishing the collagen matrix. But they also regulate the collagen matrix in a number of ways. Again, we'll actually go into that now. So here are a number of different ways that collagen, the collagen fiber, collagen fibrils, can be broken down. So there's a number of different mechanisms that over time, if that's through age or if that's through sun damage, UV damage, or if that's through any other form of radiation, through some environmental means, if that's through nutrition, like there's all kinds of environmental factors. I certainly can't list all of them. So we've got the intrinsic, which is the aging, and then we've got the extrinsic, which is environmental. And we have the most power over our environmental, obviously, through nutrition, but certainly through, sun exposure, for example. So one of the problems with the collagen matrix, what ends up happening is that with these fibroblasts, which here we've got one fibroblast, the proliferation reduces, which means that as we age and as we these cells incur more damage to their DNA, to particular sections of the cell, that they end up not splitting into more cells. So we get fewer fibroblasts over time. So instead of having many larger fibroblasts, we tend to have fewer smaller fibroblasts, which means that any collagen that would be produced out of these cells, if you have fewer of these cells, that means that you have less collagen production as a whole. Another area, however, with these fibroblasts, I did mention that they regulate our collagen matrix. Well, they regulate it through other means as well. So they don't just produce collagen, they certainly produce other proteins as well, but we're not going to go into those too much, talking about like fibrillin and these elastin sections. There's a number of other ECM proteins as well that are released. I can't think of the other names, but there's a number of them. The point is that the ECM isn't just collagen. Hyaluronic acid is another one. But it's not just about the regulation or the release of collagen, because if you're just continuously releasing collagen, then you might not actually be able to create this framework because you just have an overabundance of collagen. Some of it has been damaged through time overall, through well, as we're going to see, reactive oxygen species and just general insults, so physical damage that occurs to collagen. So you need to be able to remove collagen as well. So one of the ways, or the main way that fibroblasts are able to do that is by expressing these MMPs. So they're called metalloproteinases. So metalloproteinases are simply proteinases. They are proteins, they're enzymes that find themselves at collagen and then end up degrading that collagen. So breaking up the collagen fibrils from these long structures into shorter structures that can then be eliminated. So if you have high MMP expression, which is the abbreviation for metalloproteinases, then you have more damage or degradation of collagen. Now, this is a necessary component of the turnover of our extracellular matrix. So don't think that, again, it's not just about the production of collagen, it's also the removal of damaged collagen and unnecessary collagen. So at this point, we have one of the problems is that we have reduced proliferation of these fibroblasts. But additionally, on top of that, these fibroblasts also start to produce far, far more of these MMPs. So the MMP expression is much higher, which then leads to greater collagen damage as these MMPs then attack the collagen structure. And then finally, another area is just through like sun damage, UV radiation, as well as just aging in general. So the collagen fiber, and I mentioned physical insult. So if you end up damaging your skin, like you physically damage your skin by accident, like you bump into a wall or you cut yourself or whatever it might be, then that causes collagen damage as well through, if you're talking about through UV damage, like a direct effect of the proteins, the actual amino acids that make up the collagen matrix end up getting destroyed. So the bonds between the different atoms, or through reactive oxygen species, which are these unsatisfied molecules or free radicals that need to pull on the bonds of other atoms, of other molecules, and essentially destroy those molecules to satisfy themselves. And this is extremely pervasive as we get older, and certainly if we don't take care of ourselves. And this is an area where we can influence that through our environment. And speaking to that, these reactive oxygen species can actually also cause damage to the fibroblasts. So they can actually affect the fibroblasts to a point where you get more of this MMP expression, as well as the release of chemokines, so these inflammatory markers. So the release of these chemokines ultimately leads to the attraction of these different immune cells. So if we're talking about macrophages or Langerhans cells, which Langerhans cells are more specific to skin, but you can also find macrophages there, as well as many other types of immune cells get attracted to that region because of these chemokines, because that's what chemokines do. So the interleukin 1, interleukin 6, TNF alpha, there's a whole host of different ones. And ultimately, what immune cells do, if they're activated, they can actually lead to the generation of more reactive oxygen species. Now, the reason for that is because they're trying to eliminate something. They're trying to destroy something. So the production of reactive oxygen species in that way is perfectly normal and perfectly healthy. But the problem is if it's continuously happening in your skin, then you start to do further damage to the fibroblasts and you do further damage to the collagen matrix that's around. So this can be a cyclical situation where you're constantly recruiting more immune cells to that region, to particular regions in the skin, and then end up causing more and more damage. And ultimately, that damage looks like this. So we see a loss of skin architecture integrity. So as we see, one, less collagen, but secondly, that we see less functional collagen, so not full fibers of collagen, then we end up seeing a drooping in the skin, which is wrinkling. We start to see that occur in the dermis, and it also permeates into the epidermis as well up here. So this is clearly a pretty big problem. Now, one solution that we have is, that's proposed, is that we can consume these amino acids, so glycine, hydroxyproline, and proline, which are the most abundant when we're looking at collagen supplementation. And these three amino acids are stitched together into triple helices, essentially, over and over to create a collagen fibril. So that's the general idea of why we consume collagen peptides specifically that contain these three amino acids. And ultimately, the idea is that if we consume these amino acids, then they end up at fibroblasts. They end up getting consumed or taken up by fibroblasts, and then they lead to the generation of the collagen fibrils. So because these fibroblasts are the ones that are responsible, or at least partially responsible, mainly responsible for the generation of collagen. Now, one of the chief complaints, or what I've heard before, is that the idea that, well, we can't actually absorb collagen peptides. So collagen peptides, if you allow me to go back here real quick, is a combination of, maybe two of these or all three of these together. So these tri-amino acid structures or di-amino acid structures. And that actually turns out not to be the case. So I wouldn't even say recently, it's been relatively well known now that peptides in general, if that's tri or di, meaning two amino acids or three amino acids, tri is three, di is two amino acids that are still stuck together, instead of being broken down in the intestines into single amino acids, which is what most people think has to happen, it actually can enter the bloodstream past the intestinal wall, which is right here, these epithelial cells. It can actually do that through these transporters called pepti. So these peptide transporters. Additionally, there's some thoughts that it might be able to pass between the cells as well. We have these tight junctions that hold the cells together and connect the cells, but it seems like there's some evidence, I'll say this, there's some evidence that the collagen peptides can actually find themselves through between the cells. But the most well-known is through these peptide transporters that are found in these cells, which then get ejected into the bloodstream. So then you have these tri- and dipeptides. And what's great about this is that most people think of collagen peptides as just being like, you can just consume, if you'll allow me to go back here, you can just consume glycine, hydroxyproline, and proline, and therefore have an effect on your skin. And that may certainly be the case. I'm sure it does have an effect. If you remove those amino acids, then yes, it's going to have an effect on your skin. But there are added benefits to consuming the collagen peptides themselves, or at least that's the idea. Now, the reason for that is, yes, it can be taken up as amino acids and then can be used for the production and synthesis of collagen. Okay, that's all well known. That's the idea. That's the general idea. However, actually, collagen peptides themselves, if they're consumed as di- and tripeptides, they can actually have direct effects on reducing MMP expression. So they can have an effect on the gene expression of MMPs. So they'll bind downstream signaling proteins, and therefore then those signaling proteins either inactivate the MMPs or refrain from activating the MMPs themselves. It can be any number of different mechanisms, but ultimately the collagen peptides specifically have an effect where they reduce MMP expression, which not completely eliminate it, but just reduce it to the point where you have more of a balance of collagen synthesis to MMP expression, which would be collagen degradation. Now, additionally, collagen peptides can bind to receptors on the fibroblasts themselves and can ultimately then quote unquote convince, or genetically program these fibroblasts and other cells that are more immature cells from fibroblasts into proliferating, so that we have more of these fibroblasts, which, as I mentioned earlier, is a problem as we age. As we get older, we get fewer and fewer of these fibroblasts unless we can stimulate them through these collagen peptides, and probably through other means as well. Okay, let's go over the evidence to go from the mechanisms to the actual applicable outcomes. So the first study is to cover study 156, which does have industry ties, as you can see here, and you'll see that for all of the upcoming studies as well. So they did not receive any external funding, but all the employees are of industry, so that's a conflict of interest. So the researchers recruited 22 women, majority women, and some men. So 22 total people, mostly women, some men. Roughly 40 years of age, normal weight, healthy. Now, when I say normal weight and healthy, typically for most of these studies, they don't actually report their health. They don't report their blood sugar or anything like that, which is unfortunate and certainly a weakness of all the studies that are going to be coming up. So we're just taking it at face value, what the researchers say. The weight, I believe for this study, they did mention the weight and it did check out. So these individuals were normal weight. However, health-wise, we don't actually know. There's only going to be one study where I actually know exactly that they're unhealthy. But for the most part, all these studies, the assumption is that they are healthy. So for these individuals, it was a parallel design in this study, and so they had a placebo condition as well as the treatment condition. So the placebo condition contained everything that the treatment condition did except for collagen and ornithine. So for the treatment condition, they consumed collagen plus ornithine. And this was randomized, meaning that the participants were randomly allocated to each one of these two conditions. It was double blind, so they didn't know what they were consuming, placebo or collagen plus ornithine. And the researchers also didn't know what each participant, which condition that they were in. And the study lasted for 8 weeks. Now, here are a number of different metrics. Now, clearly that can be quite overwhelming. However, really all we need to focus on is to try to find little indicators of statistical significance. So statistical significance is set for almost all these studies. Actually, it is set for all these studies at 0.05. So anytime that you see a value less than 0.05, we don't actually see the p-values here, but once we get to the first value, I'll reiterate what I'm about to say. That if the p-value is less than 0.05, it's considered statistically significant, as in there's a difference between the two comparisons. Now, that said, all they're doing here is adding a single mark to indicate, yes, this is statistically significant. And what we can see is that even though there's a lot of numbers here, there's no difference across any of these measures. Skin moisture, TEWL, which is transepidermal water loss, elasticity, skin pH, et cetera, all the way down. However, except for TEWL, we've got our placebo, our treatment condition, and we've got our mean, which is 14.4 for the placebo condition, plus a standard deviation of 4.3, which means that the variation in the results for the placebo condition was some people had 14.8, some people had 13.6, whatever it might be. The standard deviation, the variation in the results was 4.3. So just keep that in mind. But we're most interested in the mean. And what we find is that week 0, so this is baseline, so before they were taking the placebo and before they were taking the CPO, so the collagen peptides plus ornithine, we see that there's a increase in transepidermal water loss with the placebo condition, so 14.4 to 16.2, or at least that's the assumption, because there's no increase in water loss with the collagen peptide condition. So we see that it stays roughly the same, 11.3 to 11.5, but that's not statistically significant and not even real world significant. But there is a marker to indicate that there's a difference between these two conditions. However, since the placebo condition already starts out, the baseline you can see is 14.4 compared to 11.3. You can see that the placebo condition is already experiencing greater water loss than the treatment condition at baseline before they're even taking anything. So if this would be a greater effect, this would be more impressive if the placebo condition had went from 11 to 16, because that's a 5-point difference. That's a big difference. But really all they're doing is comparing the placebo at 16.2 to the CPO condition at 11.5. So at the face value, just looking at the end results, it seems like there's a big effect, but really we also have to take into consideration where both groups started. So if we were to compare the deltas, the actual difference, 14.4 to 16.2, which is a 1.8 difference, or 11.3 to 11.5, which is a 0.2 difference, that's not nearly as much of a difference as 16.2 to 11.5. Hopefully that's clear. If it's not, feel free to ask questions. It's just the point being that we have to look at statistics more with a sharper eye than just to say, oh yeah, there's statistical difference, so therefore there's an effect. I would argue, yes, there's a statistical difference, but the effect size and the overall clinical effect is really minor. So there's not much of an effect here. And overall, on all these other measures, there's not even a statistical effect. There's just no effect whatsoever. So then if we focus in on the change in elasticity, we can see that, so this is the absolute values in elasticity. This is the actual change in elasticity. And it seems like that for the CPO condition, there is a slight improvement compared to the placebo. The placebo seems to decrease a little bit. CPO seems to increase a little bit. Overall, that leads to an overall effect. If the placebo hadn't changed at all, I don't think that you would see a statistical difference with the CPO condition. So this implicates, yes, there's a change in elasticity, but it's not that great. It's really, really minor. And the same is true for pore number. There's a reduction, but really, I think that the effect is really, really tiny. The next study is study 157. So for this one, again, this is no external funding. I could not find any conflicts of interest, so that's all good to know. However, there is a drawback of this study in that there's no blinding, or at least there's no mention of any blinding. I should say it that way. So the researchers recruited 60 women, 46 years of age, moderate to severe photoaging. So people that experienced aging from sun radiation in general, that's caused damage to their skin. And then they were randomized into either the placebo condition or a collagen plus Pycogenol and Q10 and a list of other nutrients that I'm not even going to go into. But the point is that it's not just collagen, it's the addition plus a bunch of additive nutrients that they threw in there. So this whole compound versus placebo, and the placebo was just starch. Now, they did randomize it, so they're randomly allocated to each one of these conditions. However, there was no blinding, so meaning that, or at least I don't know if there was any blinding. They didn't indicate there was any blinding. And if there is blinding after the fact that I find out, then I'll add an amendment to this video, so and in the notes, so you can see that, that I've missed something. But as far as I could see, I couldn't find any information on blinding, meaning that it's possible that the researchers knew which condition that each person was in and that the people knew which condition that they were in. And the study was only 4 weeks long. So what do we see? Well, first, on measures of actual photoaging. So for photoaged individuals, based on this metric of photoaging, we see that there's just about a doubling of photoaging. So these individuals were definitely much more photoaged. Then the healthy controls were people that had no noticeable photoaging. So they're comparing photoaged individuals versus healthy controls. And then they're going to indicate what effect the dietary supplement, the collagen supplement, plus all of its other nutrients that come along with it, what effect that has on photoaging and different metrics of photoaging. So here, great to see that, yes, the photoaged individuals definitely do have greater photoaging based off of this metric. Then they look at skin pH, skin sebum. So that's a oily material that comes out of our skin, coming from these sebum producing. It's like this section within our skin that releases this oily texture. Okay, I'll put it this way: like when you get acne or when you get some sort of skin infection, the bacteria gets stuck in that region and you see these bumps. That's partly because you see this huge buildup of sebum, because the follicle gets inundated with bacteria. Sebum in general, though, has positive effects, as in like it cleans out your skin and it's supposed to be present. Then another one is to look at elasticity, which we're going to see a lot of throughout this presentation, and skin hydration. And then the VAS photoaging score, they look at that again. So here on pH, we see dietary supplement in blue, placebo in white. We see that there's no effect across the board. So pre-treatment and 2 weeks after finishing treatment, there's no effect. The sebum production, there seems to be an increase in sebum production with the supplementation of this collagen. When we look at elasticity, there's no effect. When we look at hydration, there is an improvement in skin hydration. Now, the greatest effect is looking at this photoaging score, where we see a significant drop from, like, let's say, 6.5 to like 4.5 or 4.2 or something along those lines. Now, they actually ended up having two different populations of photoaged individuals. They had moderate photoaged and they had severe photoaged. I wonder if this measure was done with severe photoage, because if you look at the y-axis at the beginning is around 6, 6.5, 7, or I guess I should use this one right here, 6, 6.5, 7, and this one, it's only about 4.5. So clearly these are more moderate and these are more severe. So they ended up combining two different study populations together. It was pretty confusing, honestly, to go through, but the point is that they have photoaged individuals, moderate, severe. I guess it doesn't really matter that much for the overall story that we're looking at. Then they wanted to look at a number of different proteins. So they looked at fibronectin, which is one of the extracellular matrix proteins, as well as neutrophil elastase 2, which is when the immune cells infiltrate into, it's not just immune cells, but when immune cells infiltrate into the skin, that they end up releasing this elastase, which essentially degrades elastin. So you don't want that. And what we see, well, I'll get to that in just a second. Elastin is another measure. Hyaluronic acid, which is another protein which is involved in the architecture of the skin as well as the hydration of the skin, and carbonylated proteins. So I talked about reactive oxygen species. When you have reactive oxygen species that interact with proteins, functional proteins within and around the cells, then you have more of the damaged proteins, which are called carbonylated proteins in this scenario. Okay, so what do we see? Photoaged individuals in the black and the healthy individuals in the white, so non-photoaged individuals. We see that photoaged individuals have much lower levels of this connective tissue, this extracellular matrix protein fibronectin, have higher levels of elastase 2, have higher levels of elastin, which is really intriguing. This is counterintuitive to what I would have thought. Have much lower levels of hyaluronic acid, that seems to be pretty consistent, and have much higher levels of these reactive oxygen affected proteins, carbonylated proteins. Now, what happens when we actually supplement, though? Well, what we see is fibronectin levels increase, neutrophil elastase 2 decreases, elastin levels do not change. It looks like there might be an effect, but the standard error of the mean, which is, I would just recommend you look up what the standard error of the mean is. But I guess I'll give you a brief discussion on it. So here we're looking at averages, right? So we've got an average for the placebo condition is like, let's say 12. And the average for the treatment condition is, let's say, 10, right? So if we go across here, it's 10, go across here, let's say it's 12. Now, that is, the average seems to be different between the two conditions. However, the standard error of the mean indicates where the true mean actually might be. So if you have a larger standard error of the mean, that means that you have greater uncertainty about the mean that's been reported. The mean that's been reported of, let's say, 10 may be the correct mean. It's the best estimate, but it may also be slightly higher or maybe slightly lower. Standard error of the mean is essentially giving you some form of visual indication of like, okay, it could be a little higher, it could be a little bit lower. We can see that by this bar. The standard error of the mean might actually be like 11 or 11.5 or something along those lines. So there's enough uncertainty here that the statistics don't indicate a statistical difference between these two. That's a very quick lesson on standard or the mean. There's a lot more to it than what I just went over. Hyaluronic acid, we see that there's an improvement with the addition of the dietary supplement, and there is a significant reduction in carbonylated proteins with the supplementation in this condition as well. All right, study 158. So I'm not actually sure if this was industry funded or not. They don't actually report the funding, except that I saw that it's linked to a nutraceutical pharmaceutical industry of some sort. So I just went ahead and labeled this as having industry ties. Now for this one, they have 3 different conditions. They've got their placebo, as well as, which is maltodextrin, as well as a low collagen and high collagen condition. So the high collagen condition consumes 20 times more collagen than the low collagen condition. And it is parallel design and obviously randomized double-blind 8 weeks. So all good on that front. Now here they're looking at the cheek and the canthus, or canthus, which I had to look up, which is the region of the eye where the eyelids are. And we've got LCP, which is our low collagen consumption group, our HCP, which is our high collagen consumption group, and we're looking at hydration. So looking at baseline 4 weeks later, 8 weeks later. And we can see that across both conditions that there's an increase in hydration in the cheek and in the canthus. However, with the high collagen group, we see increased hydration present. So it seems that higher collagen consumption leads to an improved result. And looking at elasticity, we see that we only see an effect in the high collagen condition. So we don't see one in the low collagen condition anymore. So for elasticity, there seems to be a divergent effect. Now, additionally, with the placebo group, there seems to be a worsening of elasticity over the 4 weeks and even over the 8 weeks. But that's really neither here nor there. It just means that the high collagen consumption group experienced an improvement. And then to look at more functional outcomes, looking at the number of wrinkles, the wrinkle area, wrinkle depth, and the roughness of the skin, we can see that the high collagen consumption group experienced benefits in all 3 areas, sometimes as soon as 4 weeks. However, the low collagen consumption group only experienced benefit in the wrinkle area as well as the roughness of the skin at the 8-week mark, with greater improvements again in the high collagen consumption group. Then moving on to study 159, here this is definitely industry funded, and it has conflicts of interest in that multiple, but not all, the researchers are employees of the industry that funded the study, or employees of the company that funded the study. So pretty big deal there. Now for this, we've got our placebo condition as well as this condition that includes collagen, but also has zinc, glucosamine, and a list of other nutrients as well. So, you know, there's a lot going on there, but ultimately collagen is present as well. And this was randomized, double-blind, and 12 weeks long. Here they did something that I really enjoyed. I thought was a great idea, in that they looked at elasticity in all the subjects, but they also spread out the research from, all the subjects to 21 to 50 years old and 51 to 70 years old. And this tells us that elasticity is improved with collagen consumption in all the subjects, but we have to make sure that we're not comparing against placebo in this scenario. And the reason why is because at the baseline in both of these two conditions, the baseline values are already higher with the test product condition. So the group that ends up using the test product, they're not using it at the baseline, but they already have better elasticity. So it would be unfair to make those comparisons. So what do? We compare against the pre versus post intervention measures instead of the between subjects or between treatments of the treatment versus placebo at the same time point. Now, that is not necessarily the case for this situation where we have 51 to 70 years old, because there's no difference at the beginning, so we can compare against placebo. Now, that's being extremely strict. To be honest, if you look at the placebo, it's flatlined, and with the collagen consumption group, it continues to rise. So most likely, there's an effect against placebo as well, even with this advantage at the beginning. So something to note. Now, additionally, I should note that I wish that they had given us the average age here instead of just the age ranges. For this one, it probably doesn't matter that much because the differences between 51 and 70 are less severe than the differences between 21 and like 48 years old. So if we see improvements in individuals that are, let's say, 23 years old and they're taking collagen, that's pretty phenomenal. That means that at a young age, you should be taking collagen. But if we're talking about people that are like 47 years old, and yes, they fall within that range of 21 to 50, but it doesn't report on the individuals that are like 21 or 22 years old. So it just would have been nice to have that average value here for the average age, so we know what this is actually corresponding to or what this is helping with. Hey, if you're interested in learning about dosing and learning about optimal dosing, I've taken the information from all these studies, so the 11 studies that I went over, plus the additional 8 or 9 from the meta-analysis, and figured out what's the optimal dosing amount as well as what should be involved in that dosing. So if you're interested in that, as well as having greater access to me to be able to ask me follow-up questions and whatnot, then certainly consider joining the Physionic Insiders, which is a dedicated program where people can ask me questions, and I have tons more content in that program that's far more detailed and applicable than what I am able to provide here. So if you're interested in any of that, then certainly I'd welcome you to join the Physionic Insiders. And you can find that linked in the description box. And without further ado, let's continue. All right, let's get into Study 160. This is the first one that's really public funding. So we have taxpayer funding, no industry involvement of any sort, which is quite nice. We'll see if any of this stuff actually ends up standing up. So for this study, unfortunately, I didn't mention much on age, so we don't have like the average age or even health information. For age, they did mention in the abstract that the range was 40 to 60 years old, but in terms of the actual average age, we have no idea, which is really unfortunate and is a bit odd and seems like a pretty big oversight. But regardless, they don't mention much information on the participants, which is a drawback. However, the study is randomized, it's double-blind, and it ran for 12 weeks. It's also a parallel design, which means that we've got our placebo, which was maltodextrin in this situation, as well as collagen plus vitamin complexes. So a series of different vitamins that they ended up consuming as well. This one's pretty simple. They had one other piece of, or maybe two other pieces of data as well, but I really just wanted to focus on this one because it shows the same results as the other pieces of data as well. But the other pieces of data were on echogenicity, which is a whole nother metric that is in certain respects, at least by images, relatively subjective. So again, I just didn't feel like it was going to be as objective as looking at quantifiable numbers. And what we find here is when looking at elasticity specifically, that so we've got our baseline here, so D0 for placebo, baseline for collagen, and then D90, so day 90, or 3 months later, 12 weeks later, for each one of the conditions. What we find is that with only the collagen consumption do we see an improvement in elasticity. Now, you could easily argue that this should probably be statistically significant. I mean, the standard error of the mean is actually pretty far away from one another. I don't know if they just simply didn't do the statistics for this, because I feel like if you did do statistics, you would find an effect here. Or maybe the statistics are the p-values like 0.06 or something like that, and they just decide not to report it. So I do find this a little bit suspicious, to be honest with you. But if we take it at face value, no matter what, we can at least see that with the collagen supplementation, there's probably at least a greater effect than what we would see with placebo. Okay, study 161. Let's see what this, oh, yeah, I remember this study. So this is industry funding as well. As far as I understand, it was funded by industry, and it's possible that the researchers were also part of this research group. This were also part of the industry that funded them, which certainly could provide some conflicts of interest. Just as full disclosure, I'm not going to be going over all the data on this study. Certainly feel free to access the study. I'll have the DOI number for you so you can find it for yourself. However, the reason why I'm not reporting on all the data is because there's a lot of data and some of it gets really repetitive. Also, the data that I'll be reporting is definitely going to give you a gist of all the different confusing aspects of this study, unfortunately. So I'll still be reporting quite a lot of data from this study, but certainly keep that in mind that I'm not covering all of it. It gets repetitive, and they also end up doing a bunch of miniature measurements that may not be that telling of anything. So looking at the moisture of one particular section of one area, it's just like, it gets to be tedious after a while. Okay. Oh, right. So let me go over this. This was in 128 women, 51 years of age, healthy, visible aging signs. Just imagine being one of those people that get told, yeah, you're perfect for the study. You have visible signs of aging. Great. Thank you. Great ego boost. They had a placebo group, which was cellulose, so they definitely didn't absorb that. And then they had a treatment group, which was collagen plus glycosaminoglycan, which are CAG, which is part of the extracellular matrix, as well as chondroitin, sulfate, and they also added hyaluronic acid. And these individuals were randomized, double-blind, and the study lasted 12 weeks. Okay, so to start out, here we've got our intervention group. So this is the collagen group. Here we've got our placebo group. Here we've got our different conditions: dryness, erythema, which is tough for me to say, which is redness of the skin, and TEWL, which I went over before, but it's transepidermal water loss, so the loss of water from that particular section of the skin. And here we've got our p-value. So again, as I mentioned at the very beginning of this, 0.05 is the cutoff point. If anything is below 0.05, it is statistically significant. Anything above that means that it is not statistically significant. That's a rudimentary understanding of p-values. There's a lot more to it than that, but for our purposes, that's what we're going to use it as. And I'll get into more nuances if necessary. Okay, so we're looking at the baseline versus the week 12, and that's what this p-value is comparing. This value versus this value. The mean of this value versus the mean of this value, and that's the case, for this as well. What you'll find is that dryness improves with the intervention group. Erythema also improves with the intervention group, but TEWL does not improve with the intervention group. What's fascinating, however, is the placebo group also improved, and to near identical levels. I mean, like strong effects on skin dryness, strong effects on erythema, not quite as much, but certainly still a statistical significance, and no effect on TW. What this indicates to me is that there's one, a placebo effect, or two, that both groups are experiencing or doing something that's ultimately leading to most of these effects. So they're not collagen mediated. They're not mediated by the one disparate difference between, or the one difference between the two groups, which is collagen. So something about these two groups, they're both doing it, and it's both leading to these effects that are different from what you would expect. You would expect the placebo group not to see an improvement, the intervention group to see an improvement. Now, looking at more functional measures, here, again, we've got our means. This is the actual absolute values. Here we've got the improvement from baseline. And here we've got the number of participants that experienced an improvement. I'm not going to be focused too much on this. I guess I'll mention one quick thing. So let's look at these different metrics. The number of wrinkles, crow's feet, so the lines along the eyes, texture, smoothness of skin, and skin tone. Now, when we look at the mean for wrinkles, it seems to decrease 5.67 to 5.57. The statistical significance is above 0.05, and it's not really that close, so there's probably no effect, no improvement. However, after 12 weeks, it drops from 5.67 to 5.19, and there is a statistical significant effect. That said, the reason why this probably didn't have an effect is because 50% of individuals experienced an improvement. That means the other 50% did not experience an improvement. So that's probably why the mean ultimately leads to no statistical effect. However, once you get to 80% of participants showing an improvement, that means that only 20% did not show an improvement, and that then swings the mean further down, and therefore a greater difference versus baseline, and therefore you see a statistical difference. Now, in this situation, we do not see statistically significant differences with the placebo group. However, that is not the case for each one of these other conditions. They're all statistically significant, indicating that after 6 weeks, there's an improvement in crow's feet, skin smoothness, and differences in skin tone. But that's also universally true for the placebo. So again, there's something really confusing here. There's something, I shouldn't say confusing. I can obviously see what's happening, and I'm sure you can too. But there's something going on where both groups are doing something that's leading to most of these effects. This is not collagen mediated. Then to look at the overall improvements at the 6-week mark, there are no improvements in elasticity. There's no improvements in collagen content found in the skin. However, after 12 weeks, we do see an improvement in collagen content in our collagen condition, and we do see an improvement in elasticity. Then looking at the average wrinkle, the average wrinkle, I feel like Elmer Fudd, average wrinkle width. The average wrinkle width, we see that there's an improvement after 12 weeks, but there's not an improvement after 6 weeks. Additionally, crow's feet were also only improved after 12 weeks. And I might be able to offer an explanation for that with this data set. So again, looking at TWL, so this transepidermal water loss, we see that there's no effect across the conditions. Now, I should note here, I really like the fact that the researchers did this, because I specifically added this data set in here because when we're comparing, let's say, the end product, so when we're comparing 0.06 to 0.14, it completely doesn't take into consideration the overall travel, the distance traveled, or the amount of change, the total amount of change. Because let's just say, for example, the placebo group was already at 0.14, and this group dropped from 1.94 to 0.06, you wouldn't be able to detect that difference because you're only measuring the end results. But with this data set, they're taking the baseline and just looking at the overall distance traveled, the amount of difference over 12 weeks. So they're comparing the overall actual effect of each condition, not the end result of each condition. Hopefully that makes some sense. And what we find is that there's no difference between the two conditions in the TWL, which is consistent with what we found earlier. So the overall, no effect. Moisture, again, no effect with both of these conditions. Firmness, however, there is an effect where there's worse firmness with the placebo condition, and that persists after 12 weeks. However, there's no effect with the intervention group, or that it maintains that lower level. And so the effect is actually driven more by the placebo effect seeing a difference, as opposed to the intervention group, which is just holding steady at where it was. Elasticity, we see that there's an improvement, not after 6 weeks, because 0.09 versus 0.08, the difference was the exact same compared to baseline, their respective baselines. But the elasticity after 12 weeks was different. But again, the effect size here, so we're looking at an effect size of 0.08. It's not huge. So that's something else to consider as well. Finally, I just want to mention collagen. I'm not going to go over hemoglobin or melanin. You can read those for yourself. There's no difference. But collagen, you can see that there's a reduction in collagen in the skin at the 6-week mark. And really, I shouldn't say there's a reduction. Actually, there's no effect because the standard deviation is so wide. So we don't actually, it's the correct way to report this is that there's no effect. There's no change. However, after week 12, there is a significant change. One, this changes, it improves by 20, and this one decreases by 31. So they're going opposite directions, and that's what's leading to this massive difference between the two conditions. Okay, now let me go back here real quick. Why do we not see improvements in wrinkles here? Improvements in crow's feet, elasticity, and collagen content at week 6? It's probably because there's no collagen being deposited. So there might be some other effects that might be happening that's improving these other signs of skin aging. However, the collagen doesn't really get deposited until week 12, or from week 6 to week 12, and that's probably what's leading to these improvements over time. So, big picture, this study seems to have something going on with it, where there is a placebo effect that is unexplained, but I think most of the effects are driven by something that both groups are doing and not collagen, although collagen is probably having a small effect in certain other areas as well. Okay, study 162. Let's see here. So all these researchers are from industry, as in they're hired by the nutraceutical pharmaceutical company that's doing the research here. So extreme levels of conflicts of interest. That doesn't necessarily mean that the research is crap. It just means that, we should be cautious. We really have to compare it against less conflict of interest heavy research. So for this, what's nice is that they have the placebo group plus the collagen. So this is just collagen by itself, and the placebo is maltodextrin. It was randomized, it was double-blind, and it lasted for 56 days. Now, what's unique about this is that for one of the analyses they did, they had a number of different conditions. So they had a peptan F, which is the collagen peptides, but from fish, and collagen peptides from porcine. And this is the only data point where they're separating out the two. And then for the peptan, they're doing combination. So for peptan F and peptan P, we see that there's an improvement in skin moisture over the 8 weeks. Now, you might think, okay, well, is there a difference between those two? Well, we don't actually know because they don't do any statistics comparing the two against one another. They just show that both of them are improved versus placebo as well as versus baseline. So I can't tell you if there's any difference between if one is better than the other. It seems like peptan P would be better, but we don't actually know that. Then when we look at echogenicity, remember that's when we were looking at the collagen content, like we did in one of the previous studies. We're again comparing the placebo versus peptan, or this collagen supplement. And again, at baseline, they're identical or similar, just like they were here. And then there is a statistically significant effect at 4 weeks. However, the peptan group doesn't seem to improve any more than that at 12 weeks. But what does seem to happen is the placebo group decreases. So this is a placebo-driven effect. Not to say that the collagen doesn't have an effect. It does have an effect. But it maintains that echogenicity while the placebo group sees a decrease in echogenicity. And then looking at fragmentation, remember I talked about how the collagen fibers and collagen fibrils and whatnot have to be, lengthened, have to be stitched together, have to be strong, like think of them like columns almost, or architecture pieces that are strong and long and well put together for them to hold the skin up and for them to create this architecture. Well, if we have fragmentation, then you have fragments of these columns, these structures. Think of them like Greek ruins. The Greek buildings, when they're built perfectly the way that they are, like when they're new, then they've fully served their function. But once you fragment the pillars, you see like just fragments of pillars, obviously they're not holding up the structure anymore. So with fragmentation, we're looking at the amount of that breaking of the cuts that are caused to the collagen structure in the skin. We find with the placebo, so placebo, peptan, 0 weeks, 4 weeks, 12 weeks in terms of time, and we're looking at the overall difference. So this is compared against baseline, not against placebo. So because the placebo starts off already lower in fragmentation, and the peptan condition before, this is again before supplementation, were higher in fragmentation. Then the placebo didn't see any change, so the p-value is really far, far away from 0.05. It's 0.92, 0.93. And however, in the collagen supplementation group, there is a significant effect. There's a 17% drop in fragmentation. Then at 12 weeks, there's a 31% drop in fragmentation. Now, this might be an indication where the peptan consumption, the collagen consumption, is leading to reduced MMP expression. That's just speculation, but based on the mechanisms that we know, that the MMPs are the ones that degrade and fragment collagen, that is a likely mechanism by which this collagen is reducing the fragmentation of the collagen found inside the skin. So this is pretty cool. Study 163. So this is, I couldn't find the funding source for this. I suspected that it was public, but I don't actually know. So just keep that in mind. This is randomized double-blind. It lasted for 8 weeks. This is placebo-controlled, where they consumed maltodextrin or collagen, and it was parallel design again. For this one, they're looking at eye wrinkle volume. So we're seeing that BCP is the collagen supplementation. We see that it's gradually reduces eye wrinkle volume, so that we see smaller wrinkles. And here we see the levels of the proteins that are involved in the collagen matrix, in the extracellular matrix. Procollagen is increased with BCP. Elastin is slightly increased, and fibrillin, there's no effect. So this is more molecular, more cellular, and this is actual functional outcomes. But overall, we see an improvement. Okay, study 164, industry funding here again. So it was industry funded, but there were no conflicts of interest because the researchers actually work for an independent testing company. So, but the payment for the actual supplies and whatnot was through industry. So the treatment here is collagen plus, I don't know how to pronounce the Acerola, fruit extract, zinc, and a number of other things as well. And the placebo is the same thing except minus collagen. This was randomized, double-blind, and 12 weeks long. Here they're looking at just an assessment of collagen structure. So looking at if there's more of the collagen present or if there's less. The placebo did not seem to see a change, even though it seems like it decreases. The p-value is not anywhere near 0.05, so therefore there's probably no effect here. However, the elastin just by itself from baseline to the end of the study, which was 12 weeks long, there's an improvement in collagen structure. Now, the comparison between the two, there's also an improvement. So by 2 statistical methods, they determined that there is an improvement for collagen versus placebo. Now, this statistical method may have only been significant because this one slightly decreases, even though that one is not statistically significant. Here they're looking at a subjective marker, so they're essentially just asking people questionnaires, like questions, and just asking, hey, do you feel like your skin is less dry? Yes or no? Do you agree? Do you not agree? do you see no difference? And they're comparing the placebo versus the test product, which is obviously the collagen plus the addition of all the other things, other nutrients. And with the test product, or I guess I should say with the placebo, when the idea is when they consume the placebo, then if they subjectively think, oh, well, I think I'm taking the collagen supplement. Remember, it's double blind, so they don't know what they're consuming. But if they think they're consuming the collagen and then they assess their own skin, they're like, oh yeah, I see an improvement. That is a placebo effect. And what we find is pretty universally that there's no placebo effect, actually, that people that really took the collagen and took all this other stuff did see an improvement. They felt that their skin was less dry, that their skin does appear softer, and that their skin appears to be more supple. Now, I should bring your attention to this one right here, which is as easy and straightforward to intake. So this shows some sensitivity in terms of like like if the placebo group was like way over here and it was saying it completely disagreed, that would throw off, I think that would throw a bunch of shade at this entire questionnaire, because I'd be thinking like they're taking the exact same pill, like the form of the pill is the exact same, it's just the contents are different. So if the placebo group found it so much more difficult, I'd be like, what's going on here? But they're largely in agreement. So that's something that at least I could speak to. Okay, well, the sensitivity of the questionnaires is decent enough. So overall, in 3 metrics, there was an improvement, subjective improvement, that was not found with the placebo group. So that's cool. Good. Study 165. So Study 165 was industry funded, and I think it was performed by researchers as well in industry. So for this one, I guess it wasn't done by researchers in industry. It was at a hospital. I remember this because this is in unhealthy individuals. So while all the other studies that we've looked at have been in healthy individuals, these are 80-year-olds that are unhealthy and they're staying at the hospital for 8 weeks. So they're definitely unhealthy. This was randomized. However, there was no blinding. And so they have a control group, and the control group is people that eat normal hospital food, but they get nothing else. The treatment group is normal hospital food plus the collagen supplement, plus addition of a number of other nutrients as well. So this is not ideal. This is not a great study design, because typically it would be so easy for them to get normal hospital food plus placebo. It'd be super easy for them to do that, but for some reason they just didn't do that. So at this point now, we don't know if there's a placebo effect with this condition, if there are any sort of effects. So, but it could tell us a little something about maybe 80-year-olds, like people that are, certainly far, far more advanced in age, and people that are unhealthy if there's an effect. So stratum corneum hydration is the hydration of the top layer of skin, so what you actually see. Skin elasticity, we've gone over that multiple times, so you've already seen that before many times. So week 0 is our baseline, so before supplementation or not supplementation in the control group, 2, 4, 6, and 8 weeks, so 8 weeks in duration. What we find is the control group, there's absolutely 0 difference in skin moisture. Skin elasticity, there's 0 difference in skin elasticity, but for the intervention groups, we see that at first, there's no statistical difference, right? 0.76, 0.34, now 0.17. You're definitely trending in the direction. And then finally, there is a statistical difference as it rises up to 51.7 from 43.7, and certainly different from 41.4 in the control group. And the same is true for the skin elasticity, but it actually happens a little bit earlier on, so 6 weeks and 8 weeks. Now, what's interesting here is that it's possible that we're not seeing these effects until later on, 6 weeks and 8 weeks. Kind of like what we saw in the one study looking at the comparison of different age groups, if you'll remember this. So there's an effect already, let's say at day 30 in the younger individuals, and the effect doesn't actually appear in the older individuals until later on. So it may be a slower effect in older individuals. something to consider. We don't have the granularity to actually tell, but it's possible. So this study would indicate, poorly controlled, that collagen supplementation does help. And finally, let's discuss this meta-analysis, which includes the studies that we've been over as well as some additional studies. So a meta-analysis just groups all of the studies together and essentially creates much stronger statistical power around, so we can take a larger data set and get to a more definitive conclusion as opposed to looking at individual studies. So this one received no funding whatsoever. So it's just a reanalysis by a multitude of researchers, or just a few researchers, actually. This is a pretty small researcher set. Anyway, it doesn't matter. So as overwhelming as this looks, this is a risk of bias assessment that we see in really any meta-analysis, where they're looking at standardized questions. So looking at selection bias, performance bias. So like were the researchers blinding the participants? Were the researchers blinded? Was it a double-blind experiment, single-blind experiment, or no blinding? So as an example for that, so one of the studies that we've been over is the Nemoto study. So that was the most recent study back here, study 165. So Nemoto study, and we found, remember, that there was no blinding. So they didn't have any blinding. And if we look at the blinding for the Nemoto study, it's a minus. It's kind of hard to see here because they don't have it in color, unfortunately. Usually they have a color in green, yellow, and red, but they don't here for some reason. So it's minus because it's a high risk of bias. So if it's clear, if there's nothing there, then it's unclear on the risk of bias. If it's minus, then there's a high risk of bias. And then if it's low risk, then it tends to be green, or these positive signs. So across the board, mostly it's positive. And then this is another way of displaying it. That doesn't necessarily mean that the studies are trash, that you should throw them out or anything like that. It just indicates that there's a potential risk of bias. And if you were to reanalyze the data through what's known as sensitivity analyses, that you may want to remove those studies and see if the results still stand. So if you find a result with a meta-analysis, then reanalyze the same meta-analysis, same data, while removing the studies of high risk, of high bias, and then therefore hopefully you'll be able to determine, do those studies actually have an impact on the overall effects, or the overall conclusions of the study, or the meta-analysis. Another thing is to look at a pyramid of publication bias. So typically how you want to read this is, you think of it like there's lines coming up to here and then lines coming back down. And you want these circles, which are representative of each of the studies, to fall within that pyramid. And if they fall within that pyramid, then that typically means that there's a low risk of publication bias, meaning that the researchers aren't missing something, or that they're not looking at a particular population of individuals that have a unique quality about them that would throw them out of the average. So most of the studies should be grouped together. So the larger studies with larger sample sizes tend to be up top, and they tend to be kind of in the narrower section of the pyramid. And then the smaller studies tend to be more spread out because they have smaller sample sizes. So there's more standard deviation, less certainty about the results. So they kind of spread out across the mean line, which is this right here. And what we find is, if you've looked at these before, you would probably agree that the risk of publication bias is quite low in this scenario. All right, so to cover how to read this, these are forest plots. I'm just going to go over one of them, and then we can blast through the other ones. So how to read this is, we've got all the studies that are incorporated in measuring hydration. So looking at all the data from all these different studies are summarized right here. So we've got the studies, then we've got the mean from the collagen supplementation group, and then the placebo group. So the mean for the collagen supplementation group, the standard deviation, so the variance of the results across the individuals in that group, the number of participants in that group, then the mean of the placebo group, the standard deviation in the placebo group, the total number of participants in the placebo group, the weight of the studies, meaning that on the overall effect, so across all these studies, how much power, how much oomph does that study carry in terms of moving the overall effect? So if you aggregate all the data together, how much of the data that comes from that particular study is going to affect the overall effect of the overall conclusions? So, for example, this study, the Schwartz 2019 study, has the greatest level of weight. It's weighted 11.9%, although they're relatively similar, to be honest, across the board. And then here's the overall difference between the placebo and the collagen supplementation group. And then finally, we have the individual studies themselves, where they fall in terms of the overall effect, and then the actual overall. So putting all the studies together, all the results from all these studies together into one diamond, you see that if it's further to the right, that would favor collagen. If it's down the middle, that means there's no difference either way. And if it favors placebo, then that means that collagen has a detrimental impact on skin hydration in this scenario. And the final other thing to look at is the p-value here for the test of overall effect, to actually indicate if this is actually statistically significantly different. And it turns out that it's less than 0.05, which is, so that indicates, yes, there is a statistical difference and it's in favor of collagen. So that's how to read it. And therefore, there's certainly more nuance to that than what I've just described. But as it stands, that's how we're going to read it. And we can look at all the other measures as well. So looking at something like elasticity, again, I'm not going to go over each one of these. You should know how to read that now. But if we look at the overall effects time, and we can see that it shifts to the right, and it is statistically significant, although there are some studies that indicate the exact opposite, or there are some studies that show a really strong effect, a much stronger effect than the overall effect. But grouping all the data together, including this study and including this study, we see that the overall average with all that information leads us to have most likely an effect with collagen consumption. Then when we look at hydration again, but this is based off of the different methodologies, so the different types of measures for hydration, so by micrometer, by percentage, or by arbitrary units, they split them up again. So we have a subtotal for the micrometer, subtotal for percentage, and subtotal for AU. And what we find is that for the micrometer measure, again, it's the same measure of hydration as this, but this is everything combined. This is breaking it up by the measure. We can see that there's a statistically significant improvement with the collagen consumption. Now, if you were to look at the percentage, you'd see, okay, well, this diamond is definitely moving towards the right of this line. So you'd think, okay, well, then it probably has an effect. Well, that actually is not the case. P-value is 0.33. And the reason for that is because you only have 2 studies that make up this subtotal. And because the diamond is so wide and it crosses over into the favoring placebo, even though it's more in the collagen supplementation world, there's so much uncertainty about the results that the statistics indicate there's probably not an effect based on the data that's available, which is only 2 studies. Now, AU does something similar, but it's more certain because the studies are closer together. So there's less heterogeneity. So this is a measure of heterogeneity, 99%. It's extreme in this measure because you've got one study that's way over here. You got one study that's right down the middle. So they're very far away from one another. But these two are very close to one another. So the heterogeneity is low. And yet still, even then, with 2 studies, there isn't enough evidence to indicate that there is an effect. So there's no effect by this subtotal. So if you combine this subtotal plus this subtotal plus this subtotal, the effect is there is an effect right here at 0.01. The reason for that, why you have 2 that say no and 1 that says yes, and then we end up with yes, you'd think it'd be by majority. That's not the case because we have more studies here. We have 5 studies here. We only have 2 studies here and 2 studies here. And there's more certainty and less heterogeneity across these studies, especially compared to this one. So ultimately, and these studies also hold a lot more weight. They have 57% of the overall weight, and these only have 20% and 22%. So these are going to have the greatest effect at shifting the diamond, the overall diamond, to the right. Not to mention, these are already slightly shifting to the right. So most likely there's going to be an effect. And that's how we read hydration. So there's an effect on hydration, most likely. Now we do the exact same thing with elasticity. This one is for sure has an effect, 0.01, even with really high heterogeneity at 99%. And then this one has a really high heterogeneity at 97%, probably because of this study right here. And we see that there's no statistical effect. So that would indicate that while it is moving a little bit more to the placebo, we're essentially just saying there's likely no effect. That's all we could say. And then when we come to this one, we see that, again, there's no effect. But the overall effect is, yes, there is an effect. And then finally, to look at this, for this, they're reanalyzing the elasticity. So if we go back here real quick, they're reanalyzing these studies. However, they've removed a few of the studies that used a different method to measure elasticity. So kind of an unconventional method for measuring elasticity. So if they remove those studies, which could introduce some divergent results, do we still see the same result that we saw here, which means that adding collagen supplementation did have an effect? Well, they found that it still holds an effect. So that even when they remove those dubious studies, those kind of weird off-the-wall studies, they still see an effect. So regardless if you include them or not include them, you still have an effect. And they report both pieces of data because they want to be, well, intellectually honest, obviously. They have another sensitivity analysis as well, where they remove another study for another reason. Ultimately, that result was the exact same. So across the board, they indicate that there's no difference. Now, I should mention that this particular meta-analysis has some drawbacks. So one of the drawbacks is, as we saw with the previous studies, looking at the studies individually, that you see a reduction in the confidence that you can have because there's significant heterogeneity. Remember, if we look at like this, I-squared is a marker of heterogeneity. We see that there's a lot of these measures have really high heterogeneity. So there's a lot of studies that are kind of all over the place. But overall, if you group all the data together, it does still indicate that there's an effect. Additionally, this is not all these studies merely measure collagen. Remember, some of the studies that we went over also introduced different vitamins and different other nutrients like Q10 and things of that nature. So hyaluronic acid. So this is not a pure meta-analysis of just collagen. While we did go over some studies that did just look at collagen and we saw an effect, there were also studies that did not just look at collagen. So keep that in mind, and that is one of the limitations of this meta-analysis. All right, so at the midpoint conclusion, for those of you continuing with the insider's version of this video, we're going to go into optimal dosing. So I take all the data from all the studies that I went over, put it all together into finding what is the most effective dose. On top of that, I also go over a few other kind of details on how to maximize the effects, as well as some supporting, or a series of different supporting nutrients and the dosages that were used throughout these studies to supplement and to be actually useful for maximizing the effects of collagen supplementation. And then what happens when you cease taking collagen? Is there still an effect? Like, do you reverse all the effects that we've been going over? But with that, the midpoint conclusion at this point is that collagen is likely an effective anti-skin aging supplement through its enhancement of skin hydration, reducing wrinkles, and improving elasticity of the skin through numerous mechanisms, probably through fibroblast activation, through the reduced expression of those metalloproteinases which degrade collagen, and many other functions as well beyond the ones that even I went over. And this is really important, that collagen is likely an effective anti-skin aging supplement. Remember, a lot of the studies were industry funded or conflicts of interest in industry. So, take that with multiple grains of salt. If you just want to discount it completely, that's perfectly fair. That's not the approach that I would take. I would say that Overall, the evidence points to yes, it is effective. I think that the effects are relatively mild at this point, and I would like to see more public funding studies. But unfortunately, the NIH and other government agencies, taxpayer agencies, or nonprofits are not going to spend money on usually more vanity-related metrics. They're probably going to focus a lot more of their funding on cancer prevention, heart disease, things of that nature. So unfortunately, we have to stick to a lot of pharmaceutical industry and nutraceutical industry funding for this kind of stuff. But hopefully in the future, we'll have more, and I'll be able to corroborate some of these results or refute some of these results that we see here. Okay, well, that's what I've got for you. I hope that it was informative, and I'll hope to speak with you. I lost track of where the camera was for a second, and I'll hope to speak with you in the near future. Have a good one. Bye.